Hey everybody, this is Larry. This is me trying to do week 5 of the Leetcode weekly premium challenge. Hit the like button, hit the subscribe button, join me on Discord, let me know what you think about this one. Today we have 265 Paint House 2, a hard problem. Hopefully this is fast, because if you watch my daily video, I'm a little bit tired from marathon training. Wow, I'm just so used to saying that. But actually running the marathon, and my body's really beat, because that's apparently just like your body's immune system is a little bit weaker after running marathon, because you put it through a lot of abuse. So, alright, let's take a look at today's problem. Let's rush this a little bit, and my apologies if this explanation is not as deep as it could be, but hopefully this is okay. And I did sneak a peek to see whether I done it. I didn't look at the solution, but just that, if this video is terrible, check out the video that I did a year ago or so. Hopefully that one's better. Let's take a look. There are a row of N houses. Each house can be painted with one of K colors. What is K? Oh, I see. The cost of painting each house is so you have to paint all houses. And okay, we have how many houses? Okay, okay, I see. I mean, they hide all the inputs here inside this matrix. So okay, so let's just say, well, I don't want to use N and K because I don't know. So maybe we have H for houses is equal to length of cost, and then C for color is going to be length of cost of 0, right? Okay. So that's basically the idea. We have houses and we have colors, and we have to basically paint each house by each color. But of course, we can only we do that in a way that is not adjacent, right? So okay. So the very naive thing that I think the first thing I would do is look at the constraints, and the constraints are N and K is 120. So even if we do something like N squared times K or K squared times N, it is good enough. So I'm going to try to do the naive thing for now, and maybe naive dynamic programming, which I'm gonna just call I don't know, get paint, right? And then it is that what do? We want to paint the house. The current index is the house that we're painting, right? So H index, say the last color that we painted with, and that's it, right? Yeah, I think that should be it. So H index is the house we're painting with, and then last color is just the color of the last house. And of course this is necessary because you don't want to match, right? So yeah, so if H index is equal to H, then we're done, so we return 0. Otherwise we just try to paint every color. And actually at this point I did take a peek at the follow-up, which is N times K, and I already know how to do it. But I'm not gonna lie. We'll check whether I did it last time, but I'm a little bit tired today, as I said. So maybe we'll just talk about it, okay? But yeah, so if H index is H, we return 0. Otherwise, we just force every color, right? So for C in range of C, the cost is going to be H index of C is the current cost of painting this house for a given color, but only if last color is not equal to C, right? So then this is the cost. The recursion is going to be get paint of H index plus 1, and then the last color, of course, is going to be C, right? So it's going to be this, and then now we just have the best minimum. So we have infinity, say, and we're trying to minimize, right? Oops. Yeah. Sorry if I'm a little bit fast and not explaining too much. Like as I said, I'm a little bit tired. And again, for this one, the weekly premium challenge, I'm not going to go over DP. So I'm just going to use the Python cache. We'll go over the thing, but I'm not going to go over the whatever way. So yeah, so that should be good. Let's give it a spin. Let's give it a submit. Looks good, right? So okay, consistent is key. See me tomorrow. But yeah, so what's the complexity here, right? Well, H index can be from 0 to H. Last color can be from 0 to C, right? And then so that's the number of inputs, and for each input we do all of C work. I'm gonna sneeze. Excuse me. Oh man, do not feel great. But yeah, for each and we have O of h times c input. So total work is going to be O of h times c, or h times c squared, right? Something like that. Yeah, and that's pretty much that's the time, right? Because each one, and O of h times c space, because each input only takes all one space. Okay. Yeah. Let's take a quick look to see if I optimized it last time. I did not optimize it last time, so we'll give a quick talk about it. I'm not going to do it this video, though. I have done some. I mean, there are similar problems to this on Leetcode itself. Though obviously I'm not. You know, if you let me know in the comments. But basically, the idea is something around the pigeonhole principle. If you want to optimize this a little bit further, right? And again, my apologies if this is going really fast. Maybe you could. You know, I mean, I think this is a pretty straightforward application of dynamic programming. There are a lot of dynamic programming problems in Leetcode, so definitely work on those before working on this one. If you're struggling a little bit on understanding this one, my apologies again for this one. I'm just so not feeling well today. But yeah, but the key idea to note is that okay, we're trying to minimize this function, right? And the thing is that, well, there are a couple of things you can do. One is, keep in mind the pigeonhole principle, right? And that means that, well, if the last color is whatever, then you should be able to, if the last color is whatever, then we should be able to get all of these. But yeah. The only tricky thing is that you might have to do something about the unique colors, but I would argue that if you store maybe like 2 or 3 different things, then it really doesn't matter, right? Because if you store 3 things, then the pigeonhole principle means that you will always get a result, so you can always get it in constant time. And what I mean by that is that basically you want to store the min, right? The min of this function, right, for all of them combined, and that's easy. But except for, you know, now you're trying to figure out what happened with last color, so you go to C, right? Well, then you subtract that out. If that's the case, then you want the second min, right? And the second min should be good enough. Yeah, actually, honestly, I think that maybe even 2 is good enough. And from that, you're only making 2 decisions, whether to get the minimum color or the second minimum color, because the minimum color is the same as the one as this time. And if you do it that way, then you should be able to get it in O of h times c, because you only do 2 operations. I would say though, if you do it that way, it is a bit hard. I mean, I wrote it top down, so it looks really wonky to do. For me anyway, and I don't know, maybe there's a way to do it top down, and I have to practice it a little bit, which I apologize for not doing. And thinking through it today. But how I would do it is I would convert this to bottoms up, and then now for each of these you can see that we only care about this in the context of adding this, right? So then what I would do is that for example, if you have this is dp of h index minus 1c or whatever, right? Then I would just, for each of these, I would just add this to it, and then keep track of the min of all the previous columns, and then the second min, and then that will allow you to get this in h times c time. Yeah, that's all I have for this one. Let me know what you think. I know maybe I'm going a little bit fast. My apologies. I'm just feeling I need to pass out. I've been passing out all day, honestly, but I still need to pass out. My immune system is not doing well. So thanks for watching. Stay good, stay healthy, to good mental health. I'll see y'all later and take care. Bye bye.